Let's have a look at these exercises on exponential growth and decay. Basically, the thing that seemed to be difficult was interpreting the text and understanding what the, let's see what they call it down here. The rate of growth or decay, and also finding the factor. For example, in this case, can do like this, make it a little bit bigger. In this exercise, you deposit $1,000 into savings account and you earn 3% interest, which means that you receive 3% of the actual amount in the account each month. So it's growing, therefore it's gonna be, after 1 month the value is gonna be greater. Okay, it's going to increase by 3%. So how do we find out the growth factor, or the factor in general? Well, 1 represents 100%. So let's say that you had 0% interest, then of course it's obvious that you will just have $1,000 after 1 month. You receive nothing extra, you just have $1,000, etc. But you need to include this, so you have the initial amount. And then you're going to add 3%, but in decimal form, 3% is 0.03, okay? So the factor is going to be 1.03. If we just find out what, if we just use 0.03, we're going to get, in this case, 30. And that doesn't make sense, that we put in $1,000, we get 3% interest, and the total we have after 1 month is just $30. Then we have lost $970. It doesn't make sense. That's why we also have to include 1 or 100%, which is the initial amount. That's how we find this factor. Okay, so if something is growing, then we add this percentage to 1. In the case that something, for example, here is leaking water, so we start with 10,000 liters, and then it's leaking, so we will not have 10,000 liters after, what is the time here? Time in minutes. After 1 minute, we will have less. So then we start with 1, which is 100% of this, 1 in decimal form, minus the 6.6%. So we're going to have a factor that is less than 1, okay, because it's decreasing. That's the only thing we need to know. If we look at these examples, we have the solutions here. So if I do like this, I'm going to scroll down a little bit. So 10%. 0.10 in decimal form, and here you see some examples. It's very important that you understand these. Sometimes I see students, they answer 0.8 for 8%, but 0.8 is 80%, okay? Same thing for 7.5%, they answer 0.75, but 0.75 would be 75%, not 7.5%. Okay, so here you have whole numbers. Well, let's see, up to 10, and then you have decimal, the first decimal place here. Okay, so 7.5% has to be 0.07 goes here, and then 5. We have an example of 2.1%, 34.8. Well, think of it as 34%, which is of course 0.34, and then just continue with an 8 here, and then we get 0.348. So this is very important that we know how to transform these percentages into decimal form. And then let's go back to our exercise. Let's do a couple of these and explain these. So basically, in this example, there we go. You put in $1,000 and then you get 3% interest every month. So we just add 3% of this amount to 1,000. That should be the result here after 1 month. So what we do is we just get the calculator. We can minimize it, put it over here, and let's see. That's okay. And I'm gonna get this page. So first of all, we have to understand that the factor was 1.03. It's 100% plus 3% times the amount, 1,000. So here we have to write 1,030. And in the solutions, you can see that's what we put here, 1,030. Now, to come to this, we have to use this amount, times it by 1.03, because now we get 3% of this, and we have to add it to 1,030. Okay, so same factor, 1.03 times 1,030 is 1,060.9. And then we take 1.03 times this amount to get this, month 3, etc. And of course, there's a general formula for this. And that would be, in this case, let's say it's a balance, so let's call the function capital B of, and since it's time, I'm going to use the variable t. So the function capital B of t is equal to, and we just use 1,000, which is the initial amount, times 1.03, which is the factor, the growth factor in this, since it's increasing, to the power of t. So an example, let's see if this formula works. After 0 months, which should be this, t is equal to 0. So 1,000 times 1.03 to the power of 0. Remember that any number to the power of 0 is equal to 1. So this is basically just 1,000 times 1, which is 1,000. And that's correct. This might seem a little bit silly to find out what you have after 0 months, but we just have to make sure that the formula works for every value of t. So if we put in 1, we can study the formula here. We see that it's going to be 1,000 times 1.03 to the power 1, which is the same thing as saying times 1.03. We don't really have to write out the 1 here, but we have to understand that this is the same as putting the 1. And this calculation is exactly what we did the first time to get 1,030. The good news about this general formula is that we don't have to do this. Let's say if we want to know how much money we have after 10 months. We don't have to do this 10 times. We can just enter the value directly. So let's say What is the balance after 10 months? Well, we just put in 10 into the formula. Substitute 10 for t, 1000 times 1.03 to the power of 10. And of course, this is a calculator exercise. So 1000 times 1.03 to the power of 10. And here's the answer. We can even define this function. Of course, we can use shift B of t and then define the function. However, when we work with a calculator, it's okay to have a name and a certain variable when we work out the algebra with a pen on paper. But in the calculator, if we want to draw a graph, it's a good idea to name them like the calculator prefer. So f1 of x, so the variable is going to be x and the name is going to be f1. It's the same function. So 1000 times 1.03 to the power of x is the variable. And now it says done. We can just type the function again, f1 of x, and we see the function here. Now, if I wanted to find out how much money I have after 10 months, I just write the name of the function, in this case f1 of, not x, because I want x to be 10, and then I get the answer. So it's very easy to use this. I just type after, for example, 78 months, how much money do I have? 10,030, okay, etc. So we can even draw a graph to see how the balance is changing over time. Go up here, press enter, and now nothing is happening, and then you wonder why. Well, remember, the first value is going to be 1000, so it's going to be very high up here. So how about we change the window settings to something, well, we can start at 0, and then x is number of months, let's say 50 months, and then y, we just have to go from, well, we start at 1000, let's say we start at 900, and then we can go up to, let's say 100,000. Maybe that was a little bit too much. Yeah, that was too much with just 50 months. So let's change this into 15,000. Click OK. And now we see how the balance is increasing here. And if we continue this and we zoom out, we see that is really going to increase when we have a lot of money. 3% of that was increasing pretty fast. So here we can even study the function. Going back to this, remember, this is the function. Now let's have a look at one more example when it's decreasing. Okay, so a water tank contains 10,000 liters of water. The tank starts to leak through a hole in the bottom of the tank, and every minute 6.6% of the water remaining in the tank is leaking. First we start with 10,000 liters. First we have to figure out the factor. So how do we do this? Well, let's get some more space here. So basically, we have to figure out 6.6%, okay? 6.6% in decimal form is equal to 6%, we know that it's 0.06. And then we have 6.6, so we just add the decimal here. So that's the answer in decimal form. Now, since this is decreasing, it's not growth, it's decay. Decreasing, it's 1, which is 100%, what we start with, and then minus 6.6%. Okay, so minus 0.066. So our factor is going to be 0.934. Okay, 0.934. And now we can look at the function here. Let's define the function in the calculator. I'm gonna move it over here so we can see it. Let's start a new document. We don't have any other functions saved. Calculator. So I'm gonna name the function f1. Remember, it's easier in the calculator when we're gonna draw a graph. f1 of x. Define it. 10,000 is the initial value times, and then the factor 0.934 to the power of, and our variable is called x in the calculator. It says done. Well, let's have a look and see if it entered the function correctly. This looks about right. So let's check some values. Let's see if we can regenerate this table. So after 1, is it minutes? Yes, every minute. So time in minutes. So f1 of 1. It's basically 10,000 times 0.934 to the power of 1, which is the same as 10,000 times 0.934. And then, of course, we get 9,340. Easy to work out. After, I can actually go up. Oops, press enter. And then I will copy that and just change it into 2. 8,723.56. And we can see here in the table that that's correct. And there we go. Now, the third after 3 minutes would be f1 of 3, 8,147.81. Correct. And then after 4 minutes, 7,610.05 liters. Okay, so if we would like to study this function, how would it look like? Arrow up and then press enter. Same thing here. We start with, remember, 10,000. So that's going to be the y value. So how about we change the window settings and let's go from 0 to maybe 100 minutes. And y min is going to be, well, let's go from 0 and then to 10,000. Okay, it looks something like this. So we see that in the beginning, a lot of water is leaking through the hole. Then after some time, it's not leaking as much because we have less water in the tank. Okay, so we're kind of leaking a lot. It's leaking a lot in the beginning, and then a little bit less because we have less water in the tank. This is how the graph of the function looks like. So basically now we looked at one example where it's increasing, and we know that this factor is going to be greater than 1, because when we multiply something with a number that is greater than 1, it's going to increase. If something is decreasing or getting smaller, or something is leaking, then we have it's decreasing. We have to have a factor that is less than 1, because when we multiply any number, in this case the initial value, with something that is less than 1, the result is going to be smaller than what we start with. So these two cases, have a look at these other examples and try to figure out first for yourself, and then check with the solutions and the answers if you got it right.